So far, you've used subqueries in the select clause and in the where clause to return either a single value or return a single column of values. It is actually possible to write subqueries though that return tables, both rows and columns of data. And if you use a subquery that returns a table in your from clause, you create what's called a table subquery or a derived table. You essentially create your own virtual table that you can query from. And this can be useful for a couple of different reasons. Let's look at each of those in turn. We want to first write a query to show the average number of rentals per customer. When you think about it, that's actually a two-step process. What we first need to do is aggregate the rentals by customer, returning for each customer a count of how many rentals they've made. And then what we need to do after that is average all of those different counts. So one way to accomplish this then might be to use a table subquery and have the table subquery first return that aggregate of counts per customer and then use the outer query to obtain our average. Let's go ahead and do that now. So we'll write select from, and this time what we're going to be doing is writing a subquery that returns a table. And we want that subquery to be done on the rental table. And we want it to group by customer ID. And for each customer ID, we want to return the count, that is, the number of rentals for that customer. So this is our table subquery, and like all tables, we need to give it an alias, a name that we refer to it by. For simplicity, I'll just alias this entire table as T. Because this table subquery is just a regular, uncorrelated subquery, we can actually select it and just run it on its own. And so the table subquery itself returns for each customer the number of films that they've rented. What we ultimately wanted to do though is return the average number of rentals per customer, so we need to average over all those counts. Add a semicolon to the end, let's run this query now. So the average number of rentals per customer is roughly 26.8. So table subqueries can be useful if you need to do multiple passes over some data. You do the first pass in the table subquery itself, and then you perform the second pass in the outer query. Notice as well that when we used a table subquery, the column names for that virtual table that we created are just the column names that you have in your inner select clause. So in the outer query here, we were able to refer to a column called count, and that's because that was the name of this column here. Again, if we run this inner subquery, we see that it returns a table with two columns, customer ID and count, and so we can refer to those column names in the outer query. When you're defining the table alias, if you like, you can actually define or redefine the external column names that get used. So here, this table returns two columns. If I wanted to, I could rename the columns. So I could change the column names that are returned to customer and the count. And if I did this, I would now have to update this reference here to be to the count. And I could run that and I get the same result. I could also similarly write t.thecount to more fully qualify the reference. And again, that works too. If I tried to write t.count, that wouldn't work because I've redefined the names of the columns and I've redefined count to the count. Whether you do this though is entirely up to you. Generally speaking, you probably don't need to redefine any of the column names and you can just stick with what's being used in the select clause. Table subqueries can also be a useful way to sidestep the order of operations issues that we've touched on previously. And one of the major issues, for example, is that you can't refer to any of the derived columns that you create in your select clause in your where clause. If you recall, that just comes down to the order of operations, which is from, where, group by, having, select, order by, and then limit. If you create a new column alias in your select clause, you're actually unable to refer to it in your where clause, because the select clause is processed after the where clause. And you may even recall that we earlier did an exercise about this. I'll paste that in now. And what this query was showing us was for each film, how many times that film needs to be rented out to cover its replacement cost. And we then wanted to filter that output to only show films that needed to be rented more than 30 times to cover their cost. We can run that query, and we get 22 results. What was a little bit cumbersome about this query though, was that we needed to repeat this expression twice. Once in the select clause and once in the where clause. And that's because we simply can't refer to this break-even alias down here in the where clause. It doesn't exist at this time. Using a table subquery, we can simplify this. Let's have a look how. This entire select clause, we can now turn into its own subquery. So we can do select from, and we'll now create an entirely new subquery that encapsulates everything below. So we'll select the title, rental rate, replacement cost, and this expression as break even from the film table, and we'll treat that as its own table, and we'll alias that table as T again. So we've turned this entire select clause into its own table subquery, which again can just be run on its own. So this is returning a virtual table that has the columns title, rental rate, replacement cost, and break even. And because this now appears to be just a regular table that returns a column called break even, we're now able to refer to this break even column in our where clause. And so I can just select all the columns again and run this query, and now that works. I was able to refer to the break even column in the where clause because the break even column simply came from our virtual table that we created. So this was something of a sneaky way to sidestep our order of operations issue. If you have some really complex expression in your select clause that you want to avoid repeating in multiple other places, this is one way that you can get around that. One final way to use subqueries that can be quite useful is to actually generate your own table with values that you define. And then you can join onto that table or use it in any other query in any way that suits you. So both the rows and columns of data, the actual values that are in the table, are whatever you define them to be, rather than being based on an existing table. I'll first show you just how to create your own virtual table with values that you've defined, and then I'll include that in another query and show you where that can be useful. Let's just start off by creating a table where we define the values themselves. And we use this values keyword to do this, and after values, we specify both the rows and columns of data. In this case, I'm going to be creating my own table that has 3 rows and 3 columns. For the first row, the values are going to be short, 0, and 60. Those are the values for the 3 columns for the first row. For the second row, the values are going to be medium, 60, and 120. And for the third row, the values are going to be long, 120, and I'll stick a really high value here like 10,000. I'll close this off now. And so right now this represents a table of values, both rows and columns. And so I'll alias this table as C, and I'll have to give the columns names here. And I'll give the columns the names description, min, and max. Let me put a semicolon here and run this, and let's have a look at the results. So right now this just looks like a regular table, 3 rows of data and 3 columns. And the actual data that I've chosen here might trigger your memory from an earlier exercise we did. And in that exercise, what we did, if you recall, is we classified films as being short, medium, or long in length. We called a film short if it had a length between 0 and 60 minutes. We called the film medium if it had a length between 60 and 120 minutes. And we called the film long if it had a length greater than 120 minutes. And you may recall as well that when we wrote a query that returned all of our films and classified them as short, medium, or long, what we had to do was write a fairly complex case expression. So I'm now going to show you another way that we could have written that query. Rather than writing a complex case expression, what we could do is join the film table onto this virtual derived table that we've just made here. And if we establish just the right join conditions, we can join every film with the appropriate row from this table. So if a film has a length between 0 and 60 minutes, we would join it with the short row from this created table. By the way, if you think you can actually do this now, pause the video and go ahead and have a go at it. Otherwise, stick around and I'll show you how to write this query. So what we want to do then is join the film table onto this table. And we'll alias the film table as F, and we'll inner join this entire table. So I'll just indent it, get rid of the semicolon here. Our join condition is when the length of the film is greater than or equal to the min, and the length of the film is less than the max. And for each, we want to select the film ID, the film's title, film's length, and the new description that we obtained from the join table. Let's run this query. Having a look at the results, this film was 86 minutes, got a medium description, 48 short, 50 short, 117 medium, 130 long, so that looks like it's worked exactly as we wanted. In this case, our query that we wrote earlier using case expressions may actually be simpler, but there are some situations where an approach like this can actually make sense and ultimately make your query simpler and easier to read.